So today we're going to talk about comparing linear relationships and this concept of point of intersection. And that's some ideas that you guys are going to look at when you move into grade 10 and how to solve that algebraically and using a graph. So we're going to introduce it for the purpose of having a background so that when you see it in grade 10, it makes sense and the understanding of it is pretty good. So I'm learning about the meaning of the point of intersection when comparing two linear relationships. And I'm learning how to describe and compare when one scenario is better choice than the other scenario. So we're going to have two scenarios where we're going to look at, and we're going to be able to say, all right, this scenario is better when, and option B is better when. So we're going to be taking care of two little things, all related to linear relationships with rate of change and constant, all that's embedded, but it's a bigger connection. So that's what we're going to take a look at today with our learning. All right, so here's an example. At a local high school, the cost to attend special events depends on whether or not the student has purchased a $10 discount card. If the student buys a discount card, the cost is $5 per event. The student does not buy a discount card, the cost is $7.50 per event. Graph the relationship between the total cost and the number of events for each option on the grid. So we're going to do that here in a second. And then it says define the conditions under which the Lowell High School should choose each option. Justify your answer. So we're going to take a look at two scenarios, and we're going to look at these scenarios in the eyes of two lines. So option A, we know that we have to buy this $10 card, and that's a $1 cost, and then we're going to be paying $5 per event. Well, with the learning that we did over the last couple of lessons, we know we can make an equation out of that. We know that this is my initial value. So that is the amount that I have to start with. And this is my rate of change, because that's how much is changing per event. All right. So if I was looking at the cost would be $5 per event plus 10. All right. So we can take a look at that, and we're going to actually put that stuff on the graph. Option B says the student does not buy a card, but the cost is $7.50 per event. All right, so we've got option B. We have no initial value. All right, so didn't buy a card at the beginning, but they paid $7.50 per event. So we know, and I'm going to change colors here a little bit. We know for event B, you're not going to have a constant, but we know we pay $7.50 per event plus nothing at the start. So we can do all this on a graph. When you go into grade 10, we'll actually be able to solve that algebraically, and we'll see that moving forward. So I've got two equations here, and what you can do with this can look a little different. Some people can graph this and put it right on the chart right away. For example, we know that starts at $10, and for every step that we go across, we have go up another $5. In this case, my units are 5, 10, 15, 20, 25, and that one can be easy to graph. Another way, so this could be there, because every step is 5 units up for every step. Another way of doing this is you could make a table of values. And there's nothing wrong with that. And when we make a table of values, we can just sub in different values of n to figure out what the cost is. So if I put in 0 for n, we know that's going to be $10 because 5 times 0 is 0 plus another 10. I can evaluate that. All right. I'm gonna go skip every one. So I'm gonna do 2, 4, 6, just for argument's sake. It doesn't matter. And I can say, well, 5 times 2 plus 10. Well, 5 times 2 is 10 plus another 10. We know that is 20. And once we know our pattern, we know that that pattern increases by 10 for every 2 steps I take here. I know that this pattern is increasing by 10 because 10 divided by 2 gives you that 5. So I can plot those points and then I can draw a line. All right. Pretty good line. And I'm going to make that red. Just so that we are comparing that line. Okay, so let's go here. So this one is option A. Okay. Then I'm going to take a look at the second one. Now this one's going to start at 0. All right, and then it's going up $7.50. Well, that's pretty hard to go up. All right, but maybe I can make another table of values to figure out a pattern. So at 0, I know it's going to be at 0 to start because there's no constant. Okay. And then I'm going to put in different values for n into that equation. Well, I know that 2 events is going to cost me $15. And I hope that you could guess what it would be for 4. Well, for 4, it would be 750 times 4. And if I use my calculator, that's 30. And then I can use my rate of change and I can fill in my rest of my steps. All right, moving down. All right, so I know that for every 2 steps I do here, I'm going to increase by 15. All right, so I'm going to take a second and put that in there. 0 is 0, 2 is 15, 4 is 30, 6 is 45, and 8 is 60. All right, and now I'm going to draw my line again. All right, and I'm going to make that purple just so that you guys can see the relationship. So this one is option B. All right, so now we have to say to ourselves, okay, we've done all this work. We've made an equation. All right, we can do a table of values. We can make a graph, and now we're going to compare. Okay, so it says determine the conditions of which a student at the high school should choose each option. Justify your answer. So I'm going to actually zoom out here for a second so that you can see more of the question. All right. So if you were buying, okay, there's 2 scenarios. All right. There's one where it is for option A, you have this area and then you have this area. And there's something significant about this. that point right there is called my point of intersection. All right. So my point of intersection means it's where you go to the same number of events and the cost for both options are the same. Okay. So that's kind of cool, and I'll sum that up on the next slide. All right. So there's actually two types of answers here. All right. So I'm going to zoom back in now. All right. So if I was only going to say 2 events for the whole year, well, for option A, it's going to cost me $20. For option B, it's going to cost me $15. Option B is a better deal. Okay. But if I went for 6 events, it's $40 here, $45 here. Option A is a better deal. So what's the tipping point? The tipping point is the point of intersection. All right. So when we're looking at the comparison, we can compare using the point of intersection as a deciding point. All right. So option A is, let me figure this out. Choose option A when going to less than 4 events, because we know at 4 events it's going to cost the same amount of money. I'm going to choose option B when going to more than 4 events, because it will cost less. So we can visually see that based on that. And the reason why that works, all right, and I'm going to type this in here, so that my point of intersection is for 4 events, it's going to cost $30 for both options. Okay. So that, it doesn't matter then, right? If I only go to 4 events, it doesn't matter which option I choose. All right. But that's where the tipping point is. It's all based on the point of intersection. So hopefully that helped. But we're still using our rules of linear relationships. I know my constant, I know my rate of change. I can make a graph, I can make a table. Now we're just building up a little bit bigger understanding of these things. All right. So what is the meaning of the point of intersection? Well, we just kind of summarized that. All right. It means when having 2 linear relationships, basically 2 lines, that share a common point. So it's a point that is common between each of those scenarios. All right. So the previous example there, all right, that point was 430, which meant that for 4 events, it cost $30 for both options. All right. So point of intersection, it means when you're having 2 linear relationships, 2 lines, they share a common point. And I could see that. How can I visually see that? I can look at a graph. I can look at a table. All right. in grade 10, we're going to be able to look at that in terms of algebra. And I'll give you a little hint that deals with solving equations. So that's what I can look at. All right. All right. So that's what it looks like. All right. So 2 health clubs share, and I'm going to zoom this in now. All right. So if you need to push pause now, and then you can copy that down. All right. So 2 healthy clubs, Superfit and Body Plus, offer monthly memberships. The total monthly cost for each club is represented by the graphs below, which is following true. Now, when we have 2 lines here, the first thing you want to think about, all right, extend the lines. All right, extend the lines so they meet. So I'm going to go to my line builder, and I'm actually going to extend this line. All right. And I'm going to my line builder here. All right. And I'm going to actually just fix that up a little bit. You could also look at rate of change. So here I know it goes up there. No, that point doesn't work. That point works. Yeah, I don't know. Anyways, so if I look at this, is Body Plus always cheaper? Well, up to a point it is, but here's my point of intersection. So Body Plus is cheaper here, but it's actually more expensive here. So that one is not right. Superfit is always more expensive. Well, it is expensive here, but then it's cheaper here. So if I didn't extend the lines, I would probably say that. Superfit is cheaper if the number of events is fewer than 7. All right, if I look at that, Superfit is cheaper. No, that doesn't make any sense. BodyFit is more expensive when the number of visits is greater than 9. That's right. Okay. So by extending those lines, extend these lines so that they meet and cross, helps us to answer some of these questions. All right. Technology. All right. Jillian has 2 bank accounts. After speaking with her financial advisor, she has decided to start a savings account by putting $100 in per week. So we know from this that she's saving by putting $100 a week in. All right. Jillian also has a checking account that uses her university expenses. It's already on the graph. So we know that this part right here is my checking account. All right. So now we have to figure out my savings account. All right. Well, what variables do we use here? N and A. So N and A. All right. So this is $100 per week, because that's what it says in the question, $100 per week. So this has to be weeks. So at week 0, did I have any money to start with? Nope. And then after 1 week, she would have 100. After 2 weeks, she would have 200. All right. And heck, I can even do an equation. Well, this is 100 times n plus 0. So there's no constant. Okay. So let's look down on our chart here. Oh, these values down here don't match what I have up there. Okay. So let's figure this out. What would it be if it was 8? Well, if I look at this, I could have 100 times 8 plus 0. That's going to be 800. For 16, that's going to be 1600 because I plugged in 16 into my equation. So now I can plot the points. And draw the line. And if you have a ruler, that would be a good idea. Okay, so let's just plot the points now. All right, I'm going to use red. I started off at 0. 8 is 800, 1600, 24 if you look at the pattern on the graph. All right, and now I can sketch that line, and I'm just going to make it red so that we can see it. All right, so now this is my savings account. Okay. So what I'm going to do now is, again, I'm going to just zoom this out a little bit so that we can see it a little better. All right. And if I look at this, at what number of weeks will Jillian's savings account and her checking account both have the same amount of money? So when I'm looking at that, okay, so what number of weeks will both, that didn't work, did it? Will her savings account and her checking account both have the same amount of money? Well, what that's telling you is that's your point of intersection. Okay, so what I want you to do is push pause, and I want you to be able to tell me what that point of intersection is, and then you can come back and check it. All right. So I hope when you were looking for the point of intersection on your graph, you were looking at that point. What is that point? So if I look at this grid, all right, every 2 steps is 8, so that's got to be 4, right? 4, 8, 12, 16, 20. Oh, I can stop because I know it's at 20. So I know this is 20. And every 2 lines is 800, so this is got to be 400, 800, 1200, 1600. Well, that's got to be 2000. All right. So what that's saying there is my point of intersection. Put that back up there. Better be 20 and 2000. So the question is, what does that represent? Well, that's what I got. So in 20 weeks, and I'm going to make this into a bigger again. All right. So in 20 weeks, the savings account will have $2,000, and this blue line that's coming down will have $2,000 in the checking account. Okay. So all based on where the point of intersection is. All right. Because this represented, I'm going to put this in here, this represented weeks, and this was money. Okay, so hopefully this has helped. I think some of the questions that you're going to look at in your practice all deal with finding the point of intersection. And if you find that point of intersection, you can answer questions based on this. Okay, so try your best, give it a shot. We'll do this last question really quickly. Karina wants to rent a snowmobile for a day and considers 2 rental companies. The relationship between the total cost of renting Trail RS and the number of kilometers traveled is represented in the graph below. Off-roads charge a flat fee of $90. So what does that mean? Well, if I was looking at this, what is my rate of change? And what is my initial value? Well, if I look at this, a flat fee of $90, so I know I have to pay $90 up front. But unlimited kilometers, well, they're actually charging me nothing for my rate of change. So it's actually 0N plus 90, or just $90. All right, and what that looks like, it's like 100. So if I travel 20 kilometers, it's still going to cost me $90. If I don't go anywhere, it's still going to cost me $90. All right, 40 kilometers is 90, and from there, I can just go get off of there. Now I know that I can go straight across. Hey, okay, and let's label it off-roads. Okay, so that's what that piece of information is there. At how many kilometers is the total cost the same at both rental companies? So that's my question. So I'm going to zoom out again because it's not, this view is not helping. Okay. So how many kilometers is the cost the same? That's telling me what's the point of intersection. So if I look at the point of intersection, I know that if I look at this, 80, all right, so 80 kilometers. And if I go back, there's my 90. Okay, so I can answer the question. How many kilometers is the total cost the same? Right there. Okay, so hopefully that's helped. All right, I put some multiple choice questions in there to make you think a little bit outside of the straight math, but give it a shot, see how it goes.